Hi and welcome. I'm going to talk about chapter 6.6 in the logic book. What you'll find in 6.6 is 6.6 is basically just asking you to take a look at a couple of common argument forms and showing how these argument forms are in fact valid. This is probably of some value as we begin to set up and move into chapter 7 to see why when you have a statement like A horseshoe B, A, therefore B. This is what we call modus ponens. It's a widely accepted form of argument in which we know if you have a conditional statement and you ever get the antecedent true, you know the consequent is true. And so the way you do this is you just do an example of it, P horseshoe Q. We'll use lowercase to symbolize that these could be, it could A horseshoe B. It doesn't have to be that. It could be L dot M horseshoe N dot O, L dot M slash N dot O. It doesn't just have to be a single letter as your antecedent or consequent. It can be more longer. So we'll just do it as that way. All right. So what happens here is you need 4 lines, or we can do the inverse method. The inverse method is just to make the indirect method is just to make the assumption that this is all going to work. And what happens is you assume Q is false, you assume P is true. So if P is true and Q is false, this would actually be false. And so we have a contradiction. And that's the only possible line where that would work. And so we know that this is valid. And so you can use these truth tables in order to basically go through and check these things. So there's the first one's what we call modus ponens. And it's just basically the idea of A horseshoe B, A, therefore B, or P horseshoe Q, P, therefore Q. There's also one like modus tollens. And modus tollens is P horseshoe Q, tilde Q, therefore tilde P. Basically, it's where you take and you say, let's negate the consequent, which will then negate the antecedent. Essentially, it's saying that if it's true that Q is not true, then that means Q is false. So if Q is false, P has to be false, because if P was true, this would be a false statement. But we know we're saying this is a true statement, we're saying this is a true statement, and we're saying this is a true statement, and we would get a contradiction if we were to basically do if Q is false and P was not false. And since P is false, it says right here, Q is not true, we know P is not true. And we can symbolize that in this same argument. We can do a truth table. I'm sorry. And I messed that up. Hold on. We can do that by simply tilde Q and tilde P. So we can make the assumption of true, true, false. That makes P true and Q false. So if P is true and Q is false, we realize that this P being true and Q being false means this would be false. It causes a contradiction, and we therefore know that this is a valid argument. Okay? Now, one of the things that comes up is we have a couple of forms. We also can do this with hypothetical syllogism, where you go like this, or pure hypothetical syllogism, Q horseshoe R, therefore P horseshoe R, and you make the assumption true, true, false. The only way for this to be false is to go like that. So P is now true and R is now false. And the only way for this to be true, if the consequent is false, is for Q to be false, and P horseshoe, true horseshoe false is actually false. So we have a contradiction, and we know this is valid. And so we can now come up and say that the hypothetical syllogism, sometimes we just abbreviate HS, this right here, is in fact a valid argument form. And so we can go through modus ponens, modus tollens, hypothetical syllogism. They also do what they call disjunctive syllogism. And disjunctive syllogism is basically where you have like something like P wedge Q, tilde P, therefore Q. It's basically saying in order to get P or Q, you basically say P isn't true, then we know Q has to be true, because if P isn't true, but it's true that P or Q is true, but P is definitely not true, then you know Q is true. And we can simply symbolize this by doing our truth table. And I'm going to do the indirect method. That would make that false, and Q is false. And if P and Q are both false, it would be false. We have a contradiction, and we then know it is valid. Now, that's all great and good. We have now taken the time to show that we can have a hypothetical syllogism. We can have a modus ponens, a modus tollens, and a disjunctive syllogism. And when we get into the next chapter, we will go through a bunch of these. But what we find out is that that all of these can be proven via by using the truth tables, and they will work. You can also use it when we get into rules of replacement in 7.3, 7.4. We can also use those rules of replacement in order to, we can use the rules of replacement in order to show two statements are the same, and then we can replace them within an argument. And so that's the other beauty of truth tables, is we can also use it as we do it. So as we move on to the last chapter, we can find these truth tables, we can use the truth tables to prove the very ideas that we have, these kind of concepts of what we know works inferentially and what we know works from they mean the same thing, logically equivalent statements. So what they also use this, though, to do is to prove that there are a few kind of classic logical fallacies in the sense of not informal, but formal fallacies. I say that because we learned about informal fallacies, which are, kind of more about inductive arguments. Formal fallacies are fallacies in which the form of the argument gives the appearance that it works, but it's in fact in the form that it doesn't work. And the two main ones, the only two I'm going to show you, are what we call denying the antecedent and affirming the consequent. Now, if you recall, in an argument like an A horseshoe B or P horseshoe Q, the part before the horseshoe is called the antecedent. And the part after the horseshoe is called the consequent. So therefore, affirming the consequent means you basically affirm. You say, yes, the consequent's true. And denying the antecedent means you deny it. You say, no, the antecedent's not true. And so what happens is on a very basic level, denying the antecedent means you are trying to say, because the antecedent is not true, that the consequent is not true. And that is not true. The antecedent cannot be true if you have a statement like if you speed, you will get a ticket. Okay, that seems to be a common reason. You got a ticket, or you didn't speed, therefore you didn't get a ticket. Well, that's not the only way to get a ticket. You can also get a ticket for improper lane usage, seatbelt, not stopping at a light, all kinds of things, not stopping at a stop sign, driving in the left lane on the interstate. I mean, there's a lot of things you can get a ticket for other than speeding. And so just because you didn't speed, tilde S, tilde speed, doesn't mean tilde ticket, right? You can still get a ticket for other things. And so the same thing also is true with affirming the consequent. If I say A horseshoe B, and then you say B is true, like I got a ticket, therefore, if you speed, you will get a ticket. If you speed, you will get a ticket. And you say, I got a ticket, does that mean you were speeding? No, on the same level, you could have gotten the ticket for other things. And so we can't just make that assumption. But we can do this in a truth table very quickly. We can put P horseshoe Q. We can begin with denying the antecedent. Tilde Q, that's a tilde, it's kind of sloppy. And so we make the assumption of false, true, true, right? And this is true. That makes that true because if that's tilde, oh, I'm sorry, that's false. Sorry. Okay. So then we move over and we put Q is true, P is false. And if you look here, that works, that works, that works. So we know we don't have no contradiction. And therefore, when there is no contradiction, it is invalid. And then we can do the same thing with affirming the consequent with P horseshoe Q. Q, therefore P. And we make the assumption false, true, true. And we know P is going to be false. Q is going to be true. We just bring these values over, you know. Oh, false horseshoe, true works, false works. Therefore, there's no contradiction. This is just an abbreviation for contradiction. Therefore, it is invalid. And what we can do is we can use this to kind of find forms that don't work. Ones that we might think work but don't, and that makes them formal fallacies. All right, good luck. If I can get my screen to stop playing.